Alright, so now we're on to page 5, and we're going to start with number 51. It says graph the following polynomial. We're going to have a 0 at 5, another 0 at negative 3, and another 0 at 2. Now this one has a multiplicity of 2, so it's going to bounce here. It looks like they're all positive. The leading term would be positive, which means it's going to go up after it goes through this point. It's going to come back up to the 2 where the multiplicity is 2, and it's going to bounce, and then it's going to go through the graph at negative 3. So that's what number 51 would look like. Take a look at 52. The absolute value inequality here, we're going to graph this. It looks like it shifted 5 units to the right and 4 units down, which means the vertex is going to be way over here. It does open up. It's not flipped and it's not stretched, so it's going to look like this, except it's going to be a dotted line. So this is dotted here too. It's going to be a dotted line that looks something like that, and it's less than that, which means I'm going to shade everything below the graph. And it should have gone up 1, over 1, up 1, over 1, up 1. So it should have crossed right here. If I was a little bit more careful, it would have gone there. All right, 53. We're going to solve that system by graphing. So there's a couple ways I could graph each of these, but I'm going to get the x or the y by itself. So I'm going to start using the top equation. I'm going to add 4x to both sides. That's going to give me a negative y equals a positive 4x plus 6. But if I multiply everything by negative 1, that's going to give me positive y equals negative 4x minus 6. Well, that's going to start at negative 6, which is way down here. And the slope is negative 4, which means I go down 4 and over 1, or I can go up 1, 2, 3, 4, and left 1. Up 1, 2, 3, 4, and left 1. And that's going to be a line that looks something like that. If I graph the second equation, I'm going to subtract 4x from both sides, and so I'll have negative y is equal to negative 4x minus 2. But then if I multiply everything by negative 1, I'll have y equals positive 4x plus 2. So this is going to start at positive 2, and the slope is positive 4, which means I go up 4 and right 1, or down 4 and left 1. And that graph looks like this. And it looks like they intersect right here at this point, which is the point negative 1, negative 2. Number 54. Where's the vertex? Well, this is a little bit different because we want to figure out the vertex is wherever this is 0 inside of here. So we may not have done a lot like this in class, but let's just take a look at this. How do I make that equal to 0? Well, the x value would have to be equal to 2. So that means the vertex is going to be at 2, and it's slid up 5 units. If we were not sure about that, then we could graph our calculator. This would be grab our calculator, and we could just graph this equation. This is going to be, I think I can do this, negative 3, and then the absolute value, I think, is in math. Let's see. Yeah, math. So it's negative 3 times the absolute value of 3x minus 6. And I'm going to close the absolute value, and then plus 5. So when I graph this, change my window back to a normal window. So this is going to be negative 10 to 10, and we're going to scale by 1. So now when I graph this, yeah, so there's the point 2, 5. And you can see it opens down, and it's 3. So anyway, the vertex is whatever makes this equal to 0. Normally we say it's x minus h, but that's if there is no value in front of the x. So if there is a value in front of the x, then you just have to figure out when it's equal to 0. This is a good question to go over in class. Take a look at number 55. I'm going to multiply those two things together, which means I'm going to FOIL. 5 times negative 1 is negative 5. 5 times negative 2i is negative 10i. 2i times negative 1 is negative 2i. And 2i times negative 2i is negative 4i squared. But that's negative 4 times negative 1, which is positive 4. So if I take negative 5 plus 4, that's negative 1, and then minus 12i. Let's move on to 56. A rental car agency charges a flat rate of $23 plus $1.75 per day to rent a certain car. Another agency charges $22.25 plus $2 per day to rent the same car. Write a system of equations to represent the cost for renting a car at each agency. Well, the first one is going to be something like this. The cost is going to be $1.75 per day plus $23. The second one, the cost is going to be $2 per day plus $22.25. That's the system. Then part B, it says find the number of days for which the costs are the same. Round your answer to the nearest whole day. So I can set this is equal to C. I can set that equal to the other equation. That's going to give me 1.75D plus 23 equals 2D plus $22.25. If I get the D's on the same side, if I subtract 1.75D over here, that's going to leave me with 0.25D. And if I subtract the 22.25 over here, that's going to give me 0.75. And if I divide by 0.25, D is going to be 3. That's the answer for part B. 57. Find the slope of the equation of a line passing through those points. Well, that's just going to be negative 7 minus 7. That's y2 minus y1 over x2, which is negative 6 minus 0. That's negative 14 over negative 6, which is 7/3, is the slope. Number 58. Use the determinant to determine the number and type of solutions for the quadratic equation. Well, the determinant is this b squared minus 4ac, which usually goes underneath the radical. So the b squared is going to be 144 minus 4 times a, which is 5, times c, which is negative 4. Well, that's going to be 144 plus something, because I have two negatives, which means it's going to be positive. And if I have a positive number here, there's going to be two real solutions. If it was negative, it would be two imaginary solutions, and if it was 0, it would be one real solution. 59. Find the domain and the range of the graph below. Well, the domain is going to equal all real numbers because it goes forever to the right and forever to the left. The range, however, is going to be the y values. Let's say this is negative 5, 6, 7, 8, 9. It's not going to be able to get below negative 9. So that means it's the y values that are greater than or equal to negative 9. Interval notation would look something like this. It would go from negative 9 to infinity. Okay, if we wanted to use interval notation. And the negative 9 would be included, so I probably should put a bracket there. And then the last question on this page, we're going to sketch the graph of the following polynomial. So this is a 4th degree polynomial here. And so I could look to see where the graphs are, but if we have our graphing calculator, man, this is kind of an easy question because this is going to be x to the 4th power and then minus 9x squared, and then minus 4x, and then plus 12. And I'm just going to graph that. And I could have up to 4 zeros, and I do. It looks like it hits negative 2, and it's a multiplicity of 2 there. Then it goes through 1, and it goes through 3. So it's going to look something like that. And that is page 5. Hopefully that made sense, and we'll move on to page 6.